because this is a small presentation, and I would like to present basically a particular project, which is a very innovative project, which is Jawaharlal Nehru Stadium constructions, where basically we have used at that point of time a special type of steels, and this complete steel construction is being constructed with plates. There is no standard rolling section is been used or can be used. At that point of time, when we started innovation, because this design of this project has been done, structural design has been done by Slice Bergerman and consultant partners of Germany, and they are directly involved in these projects for the executions. There are a lot of challenges from the procurement to the coordination of multiple agencies internationally, because the membrane, it is specialized, it is a PTFE glass fiber membranes, and there are very few vendor was available in the world. Not only that, it's a cable membrane structure supported on structural steel, and this cable membrane, when it has been lifted, there is only one agency in the world was available to pull the cables, which is VSL Switzerland. And I can remember the challenge, because our deadline of this Commonwealth was frozen. And because of the 7 days delay of the erection is the structural steels, the VSL has not supplied our jacks to pull up for 1.5 months, because they have told our schedule is, already you have failed our schedule, so we are not able to deliver this material in this period, we have already shipped it to the other country. So these are the lot of challenges faced by us. In brief, this stadium consists of, there are 4 V column and 4 X columns. I am giving some inside views of the design, so that it's a very interesting project, and after that I will give a small video of the stages of construction captured, and which will give you, I believe you will enjoy these 10-15 minutes of the videography. So these are the 44 X columns, and all the columns are to the correctness of plus minus 1 mm is been allowed during these constructions. Because the entire column is with this compression ring. If there is some restriction, some tolerance is given, then these compression rings will not match together. And all the cables are also free length defined. There was no tolerance. It is actually 0 tolerance. And if there is a difference of 10 mm, then this cable has to constructed and to be reinstalled. And unfortunately, our cable supplier was from Germany. Then cable castings has been casted from Bilbao, Spain. It is fabricated again Germany and came to India. Same thing for membrane also. It's so stringent that membrane manufactured in US, fabricated in Mexico, cut to size, and came to India for the installation. So all the coordination, it's a really challenge job. And in design point of view, this is, there are, there are 44 V column and 44 X columns. Each V column is consists of something around 80 ton each. And this X column is consisting of something 120 tons. So initially we thought during the process of negotiation and all those things, people has told it has to be fabricated in the factory, and then you come and assemble, etc., etc. And what I face, we have also thought that it will be fabricated some factory and brought it to our erection site and it will install. But because of this tolerance limit, ultimately we have to decide to fabricate a fabrication yard at site only. There was no other option. And because of this tolerance, what we have to do, we have to take the entire year of the temperature. What is the temperature average? And we have to consider a particular temperature. This temperature throughout the year, this temperature will come sometime, either it is in the night or it is in the day. And all the length has been measured with total station. No tape has been used. Even after that, when we have come to the, there is a, if you see, I'll show you some. Actually, this structure is pile structure, and above the pile there are some base plates. Design considered, there is some movement in two directions, so that it can take the, impact of earthquake and wind. It has been allowed to move around 1 meter upway, up and down, the total structure, so that this fabric cannot, get overstressed. Here, in these junctions, here these are the plates, two plates about 1.5 meter by 1.5 meter, and which is been joined. I can remember that meeting when Director General of CPWD, myself, and the consultant of the German consultant representative, because there was a 0.3 mm gap between these two in few places when this wedges has been put in the junction. And we have to install the cable. He told, sir, I cannot allow, we have to zero. And I'm sorry to say, if you want to force me, I'll tell the Commonwealth Game Committee that the stadium is not safe for the event. And they will not hear you, they will hear me. So ultimately, it was a very tough time, I think it is about, say, 3 months from the back to the event date. And we have to install the cable and membrane. So ultimately, what we have done, we have taken the innovation from the metro installations, especially this, the segment installation. We have called a vendor, put some special steel, high strength steel, which they are using for the lifting of the segments. We have pre-stressed it, and then we have tightened the bolt and came to the 0-0. So these are the challenges we have faced, and so in brief, you can see this video, and I think video could not be linked here. So it is already self-explanatory about this project.
In the design, the challenge was in constructing the new iconic superstructure that was to be created around the old one. It was decided to build an envelope around the existing structure. A new facade was to be built where the old structure would be visible and the new structure would envelop it. The solution was to have a spoke wheel-based structure. The uniqueness of the design is to accommodate the distinct advantages that it provides. It has an inherent strength against earthquakes and rare wind loads. The base hinges have a significant function during an earthquake and also in the expansion and contraction during the extreme temperatures in summers and winters. Not only the base of the columns, the ends of ring elements are also pinned to the columns, allowing the ring elements to adjust themselves as when the steel expands or contracts, and also when the cables are being stretched. For an earthquake-prone city like New Delhi, lying in the Zone 4, the structure has been designed in such a way that the whole structure can sway up to 300 mm and all the cables can swing 1 meter up and 1.5 meters down. It is a monument of iconic architecture and engineering and reflects the times that we live in. Taking the cabling and membranes into consideration, it is one of its kind in the world. Thus, it posed challenges all along the way. Every aspect was in stages. In construction, normally, many of the activities are in parallel, with quite a few of them happening side by side. But here, all the activities were in series. So, if there was a delay in one activity, it hit the whole project. It was the teamwork and financial support of Shapoorji that made it possible. Shapoorji Pallonji was the company that was technically adept to execute the project and fulfill all the requirements in the scope of work. The company realized at the onset of the project the complexity in execution and put a team of enthusiastic and dedicated Indian engineers together. The Indian engineers, being very good at planning and site execution, took up the challenge and did a fantastic job. The team from Shapoorji Pallonji was an all-weather team. Regardless of the weather, they carried on with the same spirit and enthusiasm. From the time that the contract was awarded, the company and team knew that it was a fight against time, where neither could they compromise with time nor with the quality. In technical terms, the structure has piles as its foundation, a total of 272 piles, each of 1.5 meter diameter and 25 meter depth. Each pile has approximately 46 cubic of concrete and around 3 metric tons of steel. A group of piles have a pile cap and shear wall, which is an H-shaped concrete structure which directly supports the steel structure. A steel structure of 44X and V columns, each weighing 120 and 80 tons respectively. In totality, the stadium was built using 13,000 metric tons of steel. Right from the procurement of the materials onwards, the highest quality was maintained. Special steel was sourced. This steel will not decay and has a much longer lifespan compared to the normal steel used in India today. It has a very good corrosion protection, and to maintain the ductile strength under the load, the sulfur content is at 0.005%. Further, 100% ultrasonic testing was done for all the welding done in the structure. For all the fabrication, DIN codes were adopted, while maintaining an accuracy of less than 1 millimeter. The biggest hurdle crossed was that of matching the head plates of the LCR and UCR. An accuracy of 1 millimeter had been achieved, but the German consultant wanted an accuracy of 0 millimeter. In the end, 920 meters of the LCR and UCR were achieved with 0 millimeter accuracy. Ingenuity was the norm from the start. The engineers used all their knowledge and experience and created aids and processes which today serve as the industry norm. The quality of workmanship was also maintained vigorously, due to which building the structure was possible. The lifting of the 44 120 tons X columns was a feat. When the project was bid for, the thought was to lift the column in parts and pieces. When the actual lift took place, it was done in one piece. Prior to the lift, a dry run on the ground was done, where all the parts were secured and the central piece successfully lifted. The upper compression ring was the largest, measuring almost a kilometer. It was successfully put in place with an accuracy of 100 millimeters. Next to come after huge structural steel work of 13,000 metric tons was completed was the cable system of 400 metric tons. These special fully locked cables were procured from Germany. These cables were pre-cut to fixed lengths and then required to be stressed using heavy jacks to be put into its final position. This process of lifting and stressing the cables was a very slow and tedious process, which involved more than 70 heavy jacks operating simultaneously. The loads during the cable's lifting process was equivalent to the weight of 100 fully loaded aircrafts. On this kind of structure, which is on pins and is flexible and also very accurate, the steelwork had to be precise as the cables were of a specified length and could not be altered. The engineers at Shapoorji Pallonji got the accuracy of the structure to the required level and all the cables were pinned into place. Another big challenge was the membrane roofing, which is more than 50,000 square meters. The membrane is a special PTFE fabric, which is basically glass fiber fabric coated with Teflon on both sides to give it the strength required. The complete membrane now is strong enough to ride a car over it without any problem. This fabric was procured from the USA and then fabricated in Mexico to the required shape before it was brought to the project site. But installing the membrane was a very unique affair and required all the individual cables to be stressed close with 36 tons of load. This is something that was never done even in other similar structures before. The local skilled labor was trained in rope access system so that they are capable to work at heights using ropes. Along with training to climb, safety training was also given. Until the completion of the project, a safety record of 5 million man-hours was maintained. The sports lighting system was designed to ensure the lighting inside the stadium was to international high-definition TV broadcast standards. This is the first stadium in India to have such high levels of lighting. For the PA systems, there are two SPL levels. One is the normal level and the other is as the sound of the crowd will get louder, the speakers will get louder. Both the lighting system and the public address system were designed to be operated from a single point in the stadium through PLC. In the middle of all this scope of work was added the new task of creating and building a tunnel below the central field for the to and fro movement of performers during the opening and the closing ceremony. A task executed deftly by this dream team without a miss in their steps. Thus, a complex work involving coordination with multiple locations in multiple countries and involving a high degree of specialization and accuracy was completed well in time for the Commonwealth Games to enlighten the eyes of over 1 billion Indians waiting in anticipation. This is the largest cable and membrane stadium in Asia and one of the largest stadium structures in the world. Shapoorji Pallonji, with its team of young, dynamic, ingenious and innovative engineers working day and night, has helped add another feather to India's cap.